Greetings mathematicians. Today we're looking at example 2, simplifying a complex fraction using method 1. So we have addition and subtraction of fractions in the numerator and addition of fractions in the denominator. So sometimes we do have to simplify the numerator of the bigger fraction and simplify the denominator. So in order to do that, we have to get a common denominator in order to add and subtract fractions. So I'm going to be writing I'm going to go ahead and change this to a fraction 2 over 1 plus 1/2 minus 1/3, and the lowest common denominator between 1, 2, and 3 is going to be 6. A couple different ways of getting that, but since I know it's going to be 6, I now want an equivalent fraction for each of these to be written with a denominator of 6. So 2 times the ratio of 6 over 6 plus 1/2 times the ratio of 3 over 3 minus 1/3 times the ratio of 2 over 2. All of these will give me equivalent fractions that will have a denominator of 6. So 2 times 6 is 12 over 6 plus 1 times 3, 3 over 6 minus 1 times 2, 2 over 6. Now that I have a common denominator, now I can add and subtract the numerators. 12 plus 3 is 15, 15 minus 2 is 13, so 13 over 6 is actually what the numerator of the big fraction simplifies to, and now we need to do the same thing for the denominator. 3/4 plus 1/6. The lowest common denominator between 4 and 6 is going to be 12. You can do that using the lowest common multiple, or least common multiple. 6 is not a multiple of 4, but 12 is a multiple of 4, so that's where we would stop. And so we use that to write multiply by a ratio that gives us an equivalent fraction with 12 in the denominator. So that's 3 over 3. That's the ratio we multiply by. Bring the plus sign down. 1 over 6 times the ratio of 2 over 2. And now we have 9 divided by 12 plus 2 divided by 12 gives us 11 divided by 12, and that is the fraction that goes in the denominator of the big fraction. So now what I really have, and I'm going to rewrite this problem, I'll actually go ahead and write it over here. So that's going to equal 13 over 6 divided by 11 over 12. So now, and these two are equivalent to each other. I'm dividing 13 over 6, dividing it by 11 over 12. And in mathematics, we do not divide fractions, we multiply by the reciprocal of the second fraction. So that is going to turn into 13 over 6 times 12 over 11. And this is where our prime factors of numbers are going to help us. 11 and 13 are already prime, so we're going to write prime factorization of 12 in the numerator multiplication and prime factorization of 6 for the multiplication in the denominator. So 13 times 2 times 2 times 3, since 2 times 2 is 4 and 4 times 3 is 12, that's the prime factorization of 12 times 13, divided by 2 times 3, prime factorization of 6 times 11. Now that all the prime factors are here, we can start simplifying. So 2 divided by 2 simplifies to 1 over 1. 3 divided by 3 simplifies to 1 over 1. The factors that remain are what's going to be multiplied to stay in the answer. 13 times 2 is 26, because 13 times 1 is 13, times 2 is 26, times 1 is still 26. So 26 divided by 1 times 1 is 1, times 11 is 11. So that is the final answer. And I do like showing the prime factorization of the multiplication here. We could actually simplify up here as well. So for example, 12 divided by 6 simplifies to 2 over 1, and we still end up with the same answer. 13 times 2, 26, times 1 times 11, 11, still the same answer as well.